Scaling a micro-enterprise introduces a severe operational paradox. As client volume and headcount increase, the business owner's visibility into daily operations rapidly collapses. This diagram illustrates the root cause: tool sprawl. The business relies on a fragmented trinity of a CRM, inbox, and spreadsheets, failing to communicate. Notice how broken connections force manual intervention. Without strict synchronization, data packets pile up, creating rigid bottlenecks across the organization. The first measurable consequence of these bottlenecks is internal friction. Employee onboarding stalls because standard procedures are buried, and quality control degrades because staff lack immediate access to the correct operational steps. The second consequence directly impacts the balance sheet. When data requires manual retrieval, client follow-ups slow down, causing severe, trackable revenue leakage. From the owner's perspective, the operation shifts entirely into a reactive state. Instead of steering the company, leadership spends hours triaging immediate, low-level execution errors. This culminates in the ultimate symptom of systemic failure, an owner who must constantly interrupt staff to ask, "What is happening right now?" Attempting to solve this by purchasing additional, specialized software simply multiplies the network failure points. The solution requires a complete transition toward a new architectural approach. This sequence visualizes the necessary pivot, moving from a disorganized cluster of legacy applications into a centralized, autonomous architecture. We refer to this framework as a digital COO. This system actively manages workflows, moving beyond the role of simple data storage to direct the daily operations of the business. This is an empirical framework. It was engineered and stress-tested inside active, owner-led service businesses, specifically Happy Chimney Sweep and Happy Wood Stoves. This 3D isometric grid visualizes the thesis. The digital COO operates on a strict 4-layer AI operating system architecture. It functions as a single pane of glass that captures internal knowledge, runs designated workflows, and surfaces actionable insights to leadership. To understand exactly how this processes business logic, we have to deconstruct this pillar, examining each layer starting from the absolute bottom. Resolving operational chaos demands migrating data out of isolated silos and into a unified, context-aware foundation. Looking at the isolated bottom tier, we find Layer 1. This is the bedrock of the architecture, built specifically to capture raw, unstructured company knowledge. Standard operating procedures and internal FAQs are ingested here, converting static documents into structured relationships. The mechanism driving this layer is called RAG, or Retrieval Augmented Generation. RAG is an AI framework that retrieves specific, factual data from an external knowledge base to guarantee that a language model uses accurate information rather than generating its own assumptions. RAG vectorizes the static text. Vectorization is the process of translating human language into multidimensional numerical coordinates, allowing the system to instantly measure the exact semantic relevance between a user's question and the company's rules. If a staff member asks a highly niche question, such as, "How do we prep a Fuller's Prosecco container?" the network instantly maps a path directly to the specific node containing the exact procedural steps. Contrast this instant, precise retrieval with the legacy method of an employee manually hunting through outdated shared drives or interrupting a manager. This knowledge graph operates as the absolute single source of truth for the entire business. Without this centralized, vectorized foundation, any automated agents built further up the stack will hallucinate data or execute client-facing tasks incorrectly. We now move up to Layer 2, the agent workflows. This tier is where the foundational data translates into active execution. This layer houses the autonomous mechanics of the business, including initial lead triage, sequential order fulfillment, and automated collections nudges. Notice the upward data flow. These agents derive complex operational context directly from the knowledge graph beneath them, enabling sophisticated decision-making. As these agents execute hundreds of automated tasks per hour, they generate massive amounts of raw operational telemetry. This third tier, the Insight Hub, is engineered strictly to aggregate and interpret that raw telemetry. The hub produces real-time key performance indicator dashboards and anomaly alerts, catching deviations in the workflow before they have time to compound into visible errors. The most critical output here is the daily brief, which synthesizes thousands of data points into a digestible format tailored specifically for the business owner. The daily brief actively pulls yesterday's performance metrics to mathematically project today's operational risks, alongside specific recommended actions. Autonomous execution is an operational liability unless it is constantly monitored and synthesized by this overarching insight layer. This final top tier caps the architecture. Layer 4 is the command center. This serves as the ultimate human-in-the-loop layer. It functions as a unified chat and email console, where owners and staff actually interact with the system. The primary feature is the live lead feed, which utilizes automated engagement scoring to mathematically rank the priority of incoming requests. It enforces execution through SLA timers. An SLA, or service level agreement, is a strict operational rule that dictates the absolute maximum allowable time for a specific action, ensuring no communication drops. An automation status heat map gives the owner instant verification of back-end systems. At a glance, they can see that nodules like order intake and the C-change social agent are executing correctly. By handling the retrieval of data and the monitoring of tasks, this top layer successfully shifts staff behavior away from reactive scrambling and toward proactive client updates. Ultimately, this automation elevates the owner to a strategic commander, operating from a single integrated pane of glass. This is the complete operational 4-layer architecture working in a live production environment. Pilot programs running this exact configuration generated a measurable velocity increase, primarily a 30% reduction in lead response time. That specific velocity increase created a cascading mathematical effect, a 15% increase in overall pipeline conversion. These rapid, frictionless outputs stand in total contrast to the congested, manual bottlenecks created by standard tool sprawl. Organizing data structurally through this stack directly translates into measurable revenue capture and sustained operational velocity. The critical secondary benefit is resource reclamation. The business saves dozens of manual hours weekly by completely offloading reporting and follow-ups to the operating system. Migrating a legacy operation with messy data into a precise, automated architecture requires a strict logistical sequence. This flowchart maps out the commercial pathway. The required first step is the AIOS assessment, a 5-day audit designed to strictly map existing company knowledge and identify current bottlenecks. Once mapped, the immediate build phase begins. This is a 4-week launch sprint priced at £4,000 to construct the foundational layers. Long-term stabilization and maintenance are handled through a managed OS retainer, starting at £2,000 per month, ensuring the agents and knowledge graph remain updated. This phased implementation vector strictly limits the risk of sudden operational disruption during the deployment process. Adopting an AI operating system establishes the necessary architectural upgrade required to sustain and scale the modern, owner-led service business.